For the third one, we're supposed to find the moles. So we're not looking for pH, we're not looking for concentration of hydronium ion. We need to find moles of sodium formate, NaCOOH, to add to 500 milliliters of 0.100 molar formic acid, HCOOH, to make a pH 4.10 buffer. We're told that the Ka of formic acid is 1.8 times 10 to the negative 4. So, a buffer, we can use the Henderson-Hasselbalch equation. But this time, we know that the pH is supposed to be 4.10. And that's going to equal the pKa, which is going to be the negative log of 1.8 times 10 to the minus 4, plus the log of the concentration of the formate of the COOH, which we don't know. Over the concentration of the formic acid, which we do know. So by identifying the parts and where they go, we identify the one we have to solve for. And at this point, it's just a bit of algebra. This turns into 4.10 equals 3.74, that's the negative log of the Ka, plus the log of, I'm going to save space and just call it X, because that's the concentration I need, over 0.100. And that gives me, let's see, 0.36 equals the log of X over 0.100. And at this point, some people were using the trick of simply taking the anti-log of both sides. That means using my 10 to the x. So 10 to the 0.36 power is going to equal 10 to the log of x over 0.100 power, which turns us into 2.29 equals x over 0.100. So x is going to equal, I'm going to multiply both sides by 0.100, and x turns out to equal 0.229. That is the moles per liter. It's the concentration. So that's the moles per liter of sodium formate I have to have in 500 milliliters in order to make this buffer. But I don't have a liter. I have half a liter. So I take my concentration, 0.229 moles per liter, times my volume, 0.500 liters. I had to turn 500 milliliters into liters so that my units would cancel. And that means that I need 0.115 moles. Of sodium formate.